When we ask what the most powerful thing in the universe is, the answer is not simple. Power in a cosmic sense can mean energy output, destructive capacity, or the ability to shape matter and time itself. To approach this question, we must first examine the extremes of physics, astronomy, and cosmology. Each candidate for the title of most powerful is beyond human imagination, but science gives us a way to measure and compare them. The universe runs on energy. Every star, planet, and galaxy exists because of processes that unleash unimaginable amounts of it. Yet not all cosmic objects are equal. A campfire produces energy, a star produces billions of times more, but black holes, supernovae, and cosmic phenomena dwarf even the stars. Our Sun is a modest star, producing 3.8x10 superscript 2 watts of power. This means that every second, the Sun releases as much energy as billions of nuclear bombs detonating at once. Yet, on a galactic scale, the Sun is nothing extraordinary. Larger stars, such as hypergiants, can burn millions of times brighter. Some emit more energy in a few days than the Sun will in its entire lifetime. Stars achieve this power through nuclear fusion, the same process humans are trying to replicate in laboratories. Inside their cores, hydrogen atoms are fused into helium, releasing tremendous amounts of energy as predicted by Einstein's famous equation, E equals mc squared. But even the largest stars eventually run out of fuel, and when they do, they often unleash forces that dwarf their normal outputs. When a massive star dies, its death is violent. A supernova explosion releases more energy in a single moment than our Sun will emit across billions of years. For a brief period, a single supernova can outshine an entire galaxy containing billions of stars. The collapse and rebound of stellar matter creates shockwaves that spread across space, seeding the universe with heavy elements like iron, gold, and uranium. Without supernovae, planets and life would not exist. But if supernovae are among the most powerful explosions known, there are events even more extreme. A hypernova is an even larger stellar explosion, often linked with the formation of a black hole. When these explosions occur, they can generate gamma-ray bursts, the brightest form of electromagnetic radiation. A gamma-ray burst, lasting only seconds, can release as much energy as the Sun will in 10 billion years. If one were to occur within our galaxy and point directly at Earth, it could strip away the planet's atmosphere and extinguish life instantly. Gamma-ray bursts are considered among the most destructive and powerful known events in the cosmos. Yet, even they may not be the ultimate holders of cosmic power. Black holes are regions where gravity is so intense that not even light can escape. They are formed from the collapse of massive stars, but their true power lies not only in their density but in what they do to their surroundings. A black hole's gravitational pull warps space-time itself, bending the very structure of reality. When matter falls toward a black hole, it accelerates and heats up in what is called an accretion disk. The energy output of matter spiraling into a black hole can exceed the luminosity of entire galaxies. Supermassive black holes, found at the centers of most galaxies, can power quasars, cosmic beacons that shine across billions of light years. These quasars emit energy thousands of times greater than all the stars in their host galaxies combined. But black holes hold yet another form of power, their collisions. When two black holes spiral into one another, the energy released in their merger is so great that it ripples through space-time itself, creating gravitational waves. These waves were first detected in 2015 by the LIGO Observatory, confirming a prediction Einstein made a century earlier. The power of these events is staggering. In the final moments of a black hole merger, the energy radiated as gravitational waves can exceed the combined light of every star in the observable universe, if only for a fraction of a second. So far, we've considered explosions, stars, and black holes. But there is a force even greater, one that operates on the scale of the entire cosmos: dark energy. Dark energy is the mysterious phenomenon causing the universe to expand faster over time. Unlike gravity, which pulls matter together, dark energy pushes it apart. It is invisible and poorly understood, but it makes up nearly 70% of the universe. On the largest scales, dark energy determines the ultimate fate of everything: galaxies, stars, and even black holes. If power is defined as the ability to control or reshape the universe, then dark energy may be the most powerful thing that exists. It is not concentrated in one location, like a star or a black hole, but it operates everywhere, governing the cosmos itself. Another contender for the title of most powerful is the quasar. These are the blazing cores of distant galaxies, powered by supermassive black holes that are actively feeding on gas and stars. As matter spirals into the black hole, it heats up to unimaginable temperatures, releasing energy in the form of light, X-rays, and sometimes gigantic jets that extend for millions of light years. A single quasar can outshine an entire galaxy containing hundreds of billions of stars. Some quasars radiate with the power of 100 trillion suns. But quasars are not just bright. They are destructive architects of the cosmos. Their jets can sweep across their host galaxies, blowing away gas and halting the formation of new stars. In this way, quasars don't just illuminate the universe, they reshape it. They can sterilize vast regions of space, dictating the fates of galaxies themselves. Now, if we expand beyond visible objects, we reach the realm of cosmic forces. Among them, dark energy arguably surpasses everything else. Dark energy is not an explosion, a black hole, or a burst of radiation. It is the mysterious pressure that permeates the entire universe, pushing galaxies apart. Observations show that the expansion of the universe is accelerating, driven by this unseen force. The energy it exerts on the cosmos is beyond comprehension. It operates everywhere, across every corner of space, constantly at work. If you compare it with black holes or quasars, dark energy may not seem violent, but its power is ultimate because it governs the fate of the entire universe. Still, one might ask, is dark energy more powerful than a gamma-ray burst, or a black hole, or even matter itself? The answer depends on how you define power. If power is sheer explosive output, then gamma-ray bursts and supernovae take the crown. If it is gravitational control, then black holes dominate. If it is long-term influence, then dark energy surpasses all. But there is one final candidate worth considering: the Planck energy scale, a theoretical limit set by the laws of physics themselves. This is the energy level where quantum mechanics and gravity collide, where our current understanding breaks down, and where phenomena like quantum black holes might form. Nothing in the observable universe reaches this scale naturally. Yet, it represents the maximum potential energy allowed by the fabric of reality. If unleashed, a single particle at Planck energy would hold more power than anything we have ever observed in the cosmos. So, what is the most powerful thing in the universe? The truth is that the answer changes depending on perspective. For explosive energy, gamma-ray bursts. For gravitational dominance, black holes. For ultimate control of cosmic destiny, dark energy. And for theoretical limits, the Planck scale. The universe does not give us one simple answer. Instead, it offers a hierarchy of power, layered forces and phenomena that challenge our imagination, each one ruling in its own domain. Perhaps the deeper truth is that the most powerful thing in the universe is not a single object, but the cosmic balance itself, where light and darkness, gravity and expansion, energy and emptiness all play their part in shaping reality.